Good morning, everyone. Welcome back again to Operation Management. Today, we are going to focus on the schedule management, especially for the single machine scheduling. The problem that we are going to face today is about we have one machine here, we have several jobs here, and you are the decision maker. You need to select which job to process next in order to get the good performance. To do that, you need to use some kinds of rules. We will provide several basic rules for you to use, and that kinds of rule we call it priority rules. And the rules that we apply to sequencing problem are known as priority rules, or sometimes we call it dispatching rules. The best rules that will give you the best rule will give you a good result, maybe in terms of all the job complete on time or maximize resource utilization or minimize in-process inventory. That is the productivity related performance. But sometimes when you consider about the lateness or the tardiness of the performance of the scheduling system, maybe you need to measure that kind of measurement as well. Or sometimes you maybe consider utilization or inventories, right? Okay, so there are actually there are many measure of performance in terms of the good schedule that you can prepare. So today we are going to focus on it. Okay, the situation that we have here is that suppose we are at time 0, time now is equal to 0, and all the job is ready to be processed. There is one workstation and there are several jobs waiting to be processed. Okay, you are the decision maker here, and then the decision is which job should be selected first. I give you an example which consists of 5 jobs, that is A, B, C, D, and E. Each job, in order to do this job, the job has the operation time or processing time. For instance, job A need 1 time unit, okay, to complete it. Job B need 5, C needs 2, D needs 6, and E need 3, right? And each job has due date. Like job A, you should complete it within 4 days, something like that, okay? Or time unit or unit time, right? Okay, this is the example or the exercise that we are going to deal with today. And I would like to give you 4 basic rules to sequence the job. The first rule that you always familiar with is first come first serve, or FIFO, first in first out. In industry we often call it FIFO. Okay, if you go to industry, if you want to use the rule first come first serve or first in first out, you just say FIFO. Okay, all the worker there will know that this is the first come first serve rules. The logic for the first come first serve is that you will sequence the job with earliest arrival at the workstation first. Which job arrive first, you do it first, right? That is the first come first serve. And this is the way that give equality to every entity that come to the resources. Especially we use it especially in the service providing system like bank, hospital, something like that. right? Okay, this is very basic rules. Okay, in order to represent the sequence or the completion time or the activity in when you do the scheduling, you need to draw a Gantt chart. Okay, so the Gantt chart is just the graphical representation for the schedule that you can see the real performance of the system. For instance, suppose in this case, for first come first serve, I assume that the job come to the shop according to this sequence that is A, B, C, D, and E. So the Gantt chart here, okay, the x-axis represent time, y-axis represent the machine. Since we have one machine, so we have just only one y. And then, right, okay, so we are starting from job A. Job A need one time unit. So A starts from 0 and it needs 1. Okay, so complete at 1, finish at 1. And then according to the sequence that you already schedule or already sequence, okay, the next one is B. Go to B. B require 5, and since A finished at 1, B cannot start before 1, right? Okay, because the resource, only one resource, you need to share with several resources, and just only one job could be occupy the resource at one time. So you need to wait until job A finish and then job B can be start. Don't forget that you need to push all the job close to your left hand side as much as possible. In this case, whenever job A finish, you start job B. And since job B requires 5 time unit, so 1 plus 5 is 6. Job B finish at 6. Then job C require 2, right? 6 plus 2 is 8. And then job D requires 6. 8 plus 6 is 14. And then the last one is job E, require 3, right? So job D finished at 14 and plus 3 is 17. So the whole set of job will be finished at 17. Right? Okay? 17 here. This is the Gantt chart for first come first serve, and the sequence is A, B, C, D, E. And then the second priority rules that we are going to use is earliest due date. For earliest due date, we sequence the job with earliest due date first. Which job has the earliest due date? We sequence it first. Right? Okay? In this case, look at the due date to prioritize the job. You can see that job C has the due date most early, right? So you start from C, A, B, E, and then D, right? So here, C, A, B, E, D, and then you construct the Gantt chart as we did in our last example. So I will repeat it for you again. Starting from C, okay? C require 2 times unit. So 0 plus 2 is 2. And then A require 1, right? Here. 2 plus 1 is 3. B require 5. 3 plus 5 is 8. And E require 3. 3 plus 8 is 11. And D requires 6. 6 plus 11 is 17. Okay, so this is the Gantt chart for EDD. And then the next one is MST. MST is minimum slack time. The formula to calculate the slack time, slack is the due date minus operation time minus T now. According to our assumption, T now is equal to 0. So in this case, slack time is equal to due date minus operation time. Right? You select the job with minimum slack time to do first. Okay, what is the slack time? Slack time is the remaining time before the due date. For instance, suppose we have job J here. If we start job J at time 0, how many time left before due date? This is what we call slack time. So slack could be plus 0 or minus. If slack is plus, okay, if slack is negative slack, meaning that the job complete before the due date, like this one, right? Okay, completion time of the job, that is CJ here. Job J require PJ. PJ is the processing time. Okay, start at time 0, finish at PJ, and PJ is equal to CJ, that is the completion time of the job. And if the due date is DJ, so in this case, due date minus operation time or due date minus the completion time. Okay, this is the positive slack. Slack will be equal to 0 if the job finished on time. Okay, this is the due date and the job finished at the due date. And slack will be equal to negative. In this case, the job is late. Right? Okay, so don't forget that slack has 3 signs: plus, 0 or minus, depend on the status of the job, whether or not it's finished earlier or late or on time. So here, in order to apply the rules minimum slack time, you need to calculate the slack time here. So you need to use due date minus operation time or processing time. In this case, 4 minus 1 is 3, 7 minus 5 is 2, 2 minus 2 is 0, 10 minus 6 is 4, 9 minus 3 is 6. And according to the minimum slack time priority rule, you select the one with lowest value first. In this case, the sequence would be C, B, A, D, and E, right? Here, C, B, A, D, and E. And then you construct the Gantt chart, like this one, okay? And then moving on to the next one, the last one, that is SPT, that is the shortest processing time. In this case, you sequence the job with minimum processing time first. So you prioritize the job based on operation time or the processing time. In this case, the sequence would be A, C, E, B, and D, right? Here, A, C, E, B, and D, and then you construct this one. Don't forget that whenever you sequence the job according to the priority rules based on the single workstation or single machine, the completion time of the whole job will be the same. Here you can see that according to SPT, all the job will be complete or the job will be finished at 17. Here, MST again 17, EDD 17, and first come first serve 17, right? Okay, so now which one is the best one? Which one is the best priority rules? You don't know. How do you know that? You have to use the measure of performance to measure which of the sequence is the best. You don't know. Please remember that you don't know. If you want to know, you need to use the metrics. Okay, that is the measure of performance. In this case, the basic metric that you can use consists of three metrics, that is flow time, lateness, and tardiness. The flow time is equal to CJ, that is completion time, minus RJ. Actually, RJ, ready time of the job, we assume that all the job ready at time 0. So all RJ is equal to 0. So the flow time is equal to the completion time, like this one. So you got job J here, okay? Job J finish at time CJ. This is the flow time of job J. Right? Okay, this flow time. And the second one we call lateness. Lateness is equal to CJ minus DJ. That is the completion time minus due date. Here. Job J finished at time CJ and job J got due date DJ. So lateness is equal to CJ minus DJ. Similar to select time, lateness can be plus 0 or minus. Lateness is equal to plus, okay, has a plus sign, whenever job okay, we start from minus, okay. Lateness is minus when job finished earlier than the due date, like this one, because lateness is equal to CJ minus DJ. DJ is here, CJ is here, so in this case lateness is equal to minus something, right? Okay, and lateness is equal to 0 in the case that the job finished on time, and lateness is equal to plus something, okay, meaning that the job finished late. Okay, don't forget that lateness has the opposite direction, opposite sign with the select. Lateness is plus, select will be minus. If lateness is minus or negative, we got positive, select, something like that. Okay, don't forget that. Sometimes I will ask you in your final exam. And the last measure of performance that you can use is the tardiness. Okay, tardiness just only measure the job with late, the late job. They don't, this measure of performance doesn't care about the early job. No benefit for early job, but whenever the job late, you penalize immediately, like that. Okay, so you need to calculate lateness first, and whenever lateness is negative, you reset it to 0. But whenever lateness is positive, you use that value to be the tardiness, right? Okay, tardiness is equal to maximum of 0 or lateness, and tardiness always more than or equal to 0. And in order to calculate the average performance, you need to average all the performance and divide by the number of job that you are considered. For instance, suppose you would like to find the average flow time or mean flow time, that is a summation of Fi divided by N. Mean lateness is summation of Li divided by N, or tardiness, mean tardiness, summation of Ti divided by N. The lower the value, the better the performance, right? Select the lowest one always. That is the best one. That is the best sequence, or that is the best Gantt chart, or that is the best priority rules that you can select. Okay, I would like to show you how to select the best priority rules for each measure of performance. So let me start from first come first serve. Okay, you have to prepare the table like this one. The heading of the table consists of job order, operation time, flow time, due date, lateness, and tardiness, like this one. Okay, very simple. Then according to first come first serve, the sequence you have to look at the Gantt chart. Okay, sorry, I put the Gantt chart here. Okay, first come first serve, the sequence is A, B, C, D, E. You put A, B, C, D, E here, and then operation time of A. Okay, just copy from the question 15263, like that. And the flow time, okay, the flow time is quite simple. You just copy from the Gantt chart because you have already done this one. So you have the sequence, you have the schedule for each job, and then the flow time is equal to the completion time. This is the completion time of each job. You just copy it from Gantt chart 1, 6, 8, 14, and 17. Put it here 1, 6, 8, 14, and 17. Now you can compute the average flow time or mean flow time by summation of this number and divide by 5. We got 9.2 here. And then the due date for each job, okay, A, B, C, D, E. Lateness is equal to flow time or completion time minus due date, right? In this case, 1 minus 4 is minus 3. 6 minus 7 is minus 1. 8 minus 2 is 6. 14 minus 10 is 4. 17 minus 9 is 8. Again here, if you want to calculate mean lateness, that is going to be minus 3 minus 1 plus 6 plus 4 plus 8 and divide by 5. You got 2.8. And the tardiness is 0 or lateness, maximum of 0 and lateness. So very simple, just remember that whenever you see negative sign, you just reset it into 0. Okay, minus 3, 0, minus 1, 0. And whenever you see positive sign, copy it 6, 6, 4, 4, 8, 8 here. And then mean tardiness is equal to 0 plus 0 plus 6 plus 4 plus 8 divided by 5. You got 3.6. So according to the first in first out, the value that you can get from the Gantt chart or the performance of the first in first out is the performance of first in first out in terms of flow time. Mean flow time is 9.2. In terms of mean tardiness is 2.8, and in terms of tardiness is equal to 3.6, right? And then for the EDD, okay, you move to EDD, right? For EDD, the Gantt chart is CABED. Put it here, CABDE, and then operation time of C is 2, A is 1, etc. here. And for flow time, again, just copy it from Gantt chart 2, 3, 8, 11, 17. Put it here 2, 3, 8, 11, 17. And mean flow time is equal to 2 plus 3 plus 8 plus 11 plus 17 divided by 5. You got 8.2. And put the due date for each job here. And lateness, again, Fj minus Dj or Cj minus Dj, the same, right? 0 minus 1, 1, 2, 7. Okay? And then mean lateness equal to 0 minus 1 plus 1 plus 2 plus 7 divided by 5. You got 1.8. And for lateness 0, 0, minus 1, reset to 0, 1, 1, 2, 2, 7, 7, and then average this number, and then you got 2.0. Okay? Moving on to the next one, that is the MST. For the MST, the Gantt chart for MST is like that. CBADE. Put it CBADE. And then the operation time And for the flow time, just copy it from the Gantt chart 2, 7, 8, 14, and 17. 2, 7, 8, 14, and 17. And put the due date here. And compute lateness. Okay? 2 minus 2 is 0. 7 minus 7 is 0. 8 minus 4 is 4. 14 minus 10 is 4. 17 minus 9 is 8. And then for the tardiness, okay? Every number is positive, so just copy here, right? And then calculate average flow time, average tardiness, and average lateness and average tardiness here. Moving on to the last one, that is the SPT. Look at the Gantt chart of SPT. The sequence is ACEBD here. ACEBD. And then this operation time, and the flow time just copy from the Gantt chart, that is 1, 3, 6, 11, 17. 1, 3, 6, 11, 17. And then copy the due date, right? 4, 2, 9, 7, and 10. Lateness is equal to completion time minus due date, or flow time minus due date. Okay? You get this column, and then the last one here, you got minus 3, reset to 0, 1, 1, minus 0, 4, 4, 7, 7, and then find the average flow time, average lateness, average tardiness. Right? Okay, now you are ready to compare which one gives the best performance in terms of which measure. For instance, suppose you want to know that which priority rules give you the best performance in terms of flow time. You just look at the flow time of each one. The best rule will give you the lowest mean flow time. Okay? For SPT, you got 7.6. MST 9.6, EDD 8.2, and FIFO you got 9.2. So in this case, which one is the best? SPT, right? SPT is the best. According to lateness, mean lateness, which one is the best? This is for SPT 1.2, 3.2 for MST, 1.8 for EDD, and 2.8 for FIFO. So again, SPT is the best for lateness. And for tardiness, SPT gives you 2.4. MST gives you 3.2. EDD gives you 2.0. And the last one, first come first serve or first in first out, gives you 3.6. The lowest value for mean tardiness is EDD. Right? Okay, this is the conclusion. Which one will give, which priority rules give you the best performance for which measure of performance. Okay, so come to our first assignment after the midterm. Please don't forget that every material or every content before the midterm will not be appear again in your final exam. Okay, we start the new content. So the assignment that I would like you to do is quite similar to your final exam. We give you 6 different jobs A to F, and give you the operation time and give you the due date. And I would like to ask you to apply first come first serve, EDD, MST, and SPT priority rules to this set of job. Okay, but assume that the first come first serve has to obey with this sequence, that is D, E, A, F, B, and then C. Okay, use this sequence for first come first serve or FIFO. And then I asked you which rule is the best for average flow time, average lateness, and average tardiness. Note that you need to draw the Gantt chart. Okay, in your final exam, you also need to draw the Gantt chart. I will give you some marked for the Gantt chart. Okay. Hope you enjoy this exercise. Hope you enjoy this chapter, and hope you can finish the exercise. See you again next week. Thank you.